Are you children ready to ponder? Because I'm ready to ponder. Let's ponder here. If the two sequences below, or in the two sequences below, predict the value for t sub n as n gets very large. Okay, so we're predicting a very far out value in these sequences. So for the first one, let's jot a couple things down. 1/2 to the first is 1/2, and then 1/2 to the second is 1/4. Then I'd have 1/8 when I raise it to the third, and then 1/16, so on and so forth. It keeps getting smaller, 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 right? Well, what's it eventually approaching? Well, I think it's going to get really, really close to 0. We're cutting something in half over and over and over. But as you know, if you keep cutting it in half, it's never going to get to 0. It's just going to get infinitely smaller and get close to 0, okay? So approaches 0. Cool. All right. How about the next one? Well, I'd have 2, and then 2 squared is 4. Then 2 to the third is 8. Then it's 16, so on and so forth. That's approaching, well, it keeps getting larger and larger, so it's approaching infinity. It's going to just keep going up. Keep going up. There's no limit, okay? Or the limit's infinite. The sky's the limit, rather. Okay, there we go. We'll talk limits another time. All righty. What would happen? Ponder number 2. If you didn't get enough pondering in that first one, we're going to ponder it again. What would happen to the sum of the series for each t sub n? So what if we were to add them together, right? We already talked about sums, right, with geometric series. Well, let's see here. I would have 1/2 plus 1/4 plus 1/8 plus 1/16, so on and so forth. Now, I'm thinking a tape measure here because I'm always strapped. Now, if I were to pull out this tape measure, and let me make this a little larger here. Okay. Hi. Now, it does not matter what inch mark we are on, but I will try to get this as in focus as possible. Okay. So let's say I start at the 7 here, right? Whoop, there we are. Okay. Now, the halfway mark is right here. That's the halfway. Okay, it's 1/2 inch. Now, then if I add a 1/4 inch, I'm here. Then if I add 1/8 of an inch, which was the next one, I'm here. And then if I add a 16th, that's the little line, then this doesn't even have 30 seconds, but that'd be 1/2 again, then 1/2 and 1/2 and 1/2. As you can see, I keep just getting closer and closer and closer to 8. I keep adding a number that gets smaller and smaller and smaller, that number that's approaching but never getting to 0. If I keep on adding a smaller and smaller and smaller number, eventually I'll get insanely close to that here. That infinite sequence, or that infinite series, will add up to 1. That's pretty cool. At least that's our thought there. That's math for another crazy cool day. But 1, perhaps? Cool. Now the next one, I would have 2 plus 4 plus, not 6, 8 plus 16. That's going to end up going to, well, if we keep adding bigger and bigger numbers, sky's the limit once again, right? It's just going to go to infinity. It's going to keep going. Keep going. Woo! All right. Let's keep going. Cool. So some vocab that gets mixed up, and honestly, I've mixed up myself as well. I'm not perfect. So when we find the sum of a finite sequence, like we did in the previous video, we're actually finding a series. The series is the sum of the terms of the sequence. Okay, there we go. Let's jot it down. Put it down in the notes. It was like when college professor said, now write that down. Okay. So when a sequence contains an infinite amount of terms, sometimes they'll converge, and other times they will diverge. I actually mentioned that in the previous video, but real quick. And so we're going to check it out later. Now is later. Okay. So an infinite sum of that form, a plus a sub 1 times r plus the first term times r squared, so on and so forth, with the common ratio r, it's called an infinite geometric series, where it goes from k equals 1 all the way to infinity. Okay? And we'd have a sub 1 times r raised to the k minus 1. All right. Cool. Lovely. Now, what does it mean to converge? So when my common ratio is less than 1, the absolute value of that common ratio, because it could be a negative number as well, right? But the absolute value of it is less than 1. That's when it converges. So if, like say it's 1/2, the numbers kept getting smaller, 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 smaller. It's converging, okay? If I had like R was -2, well, the absolute value of that is 2, which is larger than 1. That diverges, okay? It's negative, which I know is less than 1, but that's why the absolute value bars are very important, okay? So the formula for this would be my first term divided by 1 minus my common ratio. Or you can plug it into your calculator, but if it asks to write it out, or you're given something and you need to figure things, it's nice to know how to do either one, okay? Lovely. Cool. So there we go. If you're wondering, like, wait, where's the diverging one? You're not going to get a sum of that, right? It's going to keep getting bigger. It's going to be infinity, right? So there's no formula for that one. Okay, so let's try one, and then we'll call it in this video, and we'll do a second video with some more practice later on, just based on how the scheduling worked out this year. It is a wonderful, weird block scheduling pandemic year. You know, if we were watching this later on, you'd be like, why did they break it into 2 videos? There was a time where we had crazy schedules and stuff. All right. So we have determine whether the geometric series converges or diverges. If it converges, find its sum, right? If it diverges, not going to find its sum. So I have 1/2, then -1/4, then 1/8, then 1/6. So this is getting the numbers, the absolute value of the numbers are getting smaller, right? What is that common ratio? Well, R is going to be 1/2 here. -1/2, right? It's alternating, positive, negative. Cool. All right. Now we're going to find its sum. I could use my calculator, but I'm going to use that new awesome formula, right? Because that sounds awesome. Cool. And just to remind ourselves, -1/2, the absolute value of it is indeed less than 1. That's why it converges. That's why we know. Okay. So I'd have my first term is 1/2 divided by 1 minus my common ratio. So I have 1/2 divided by, that becomes addition to this 1/2, which is 3/2, and then I'd multiply by the reciprocal. So that'd be 1/2 times 2/3. So my sum is 1/3. They're going to add up to 1/3. Woo! Fractions. I showed the work in case you're like, I don't know how to do fractions. I forgot. Don't worry. I'm here for you. I'm here for you, children. All right. That's a quick video. Hope you guys enjoyed. We'll break it up. The next one. Yeah. America, freedom, rock and roll. Costco, Riverdog Jenny on the gram, and of course, Yo-Ro.